Live. So, hi everybody. It's been a little while. I think I had a pretty bad weekend with being sick and whatnot, so we kind of didn't do one yesterday.
Yep.
Or earlier today, but we're back, and I think we got a lot of cool stuff to show you. I've changed the title for this one. I called it what did it call it? In which we attempt to automate repos or something like that. But the upshot is, I mean, let's take it from the top. The thing that me and Ryan started to try to do is to harness collective intelligence, and then the AI thing came out, and we're like, okay, well, that's super important. So, with GPT-4, I mean, and we should probably focus on this. And then we focused on that for a while, blew ourselves away a few dozen times in a row, and then we kind of like adjusted to it. I think after that we tried to continue building something about what did we try to build something before the editor, the chat interface?
We were trying to tease out. We tried to use a bunch of different stuff. Like we tried Node-RED. We were trying to have like a React admin page that would build itself. But it was all sort of circling around this idea of like having the thing build itself in response to feedback.
Right. Right. Yeah. So basically, I think we've been, ever since we tried the AI thing, we started, working with GPT and that kind of stuff. We have been looking for ways to compound our gains, right? Because having GPT at your disposal is cool, but if you get it to do something cool, you don't really, you can't really sort of store that and get it to keep, like, be able to like bring that skill back sort of on demand, or like compound your gains by like combining different cool things or whatever. You kind of have to do yourself over and over. And really the thing we've been focusing on a lot is automating coding. So these are kind of two different but related things. And the third one is, I think that collective intelligence things is still in our minds. And if you really, I think the realization we've had, I think slowly over time and then all at once this morning, is that the better sort of true form of what we're trying to build is a GitHub repo, because GitHub repo has a lot of baked in capabilities for managing things like having a change and then embedding it, testing things, storing issues about what you want to change. It's very sort of disciplined about doing all sorts of standard moves. And not only that, but you can, if you find the right tools and you put them together, you can do even more than that. But long story short, we think that plus a lot of the stuff that we've figured out about ChatGPT can be put together to make, I think on the limit, a fully automated repo, let's call it, right? So imagine a repository that it sort of maintains some sort of homeostatic level of functionality, right? Like it's a library that can do certain things and it can test itself. It can update its own tests. It can update its own dependencies. It can sort of do a thing for whatever that means for a given point in time, automatically sort of updating itself over time without really having anybody to take care of it. And the idea is that once you have that semi-stable sort of core of functionality, you can then create issues. And really, an issue and a prompt it's hard to distinguish them, right? You can sort of imagine having a conversation with an LLM over an issue, which results in a pull request, which then gets automatically tested and merged and released. So at that point, it's kind of like a loop that keeps going, right? Until you kind of nudge it, and then it kind of shifts itself and then keeps going again. So then the only thing the user does is the nudging, right? Which is kind of what you want. You want the thing to have a, for anything complex you want to make with a large language model, you you want to have ways to sort of maintain a baseline of sanity, right? So you don't start creating garbage. You want that to retain its quality over time, and you want to be able to improve it without, again, losing your functionality. And also, like, you want to track your history. You want to be able to compare different alternative paths before choosing one, et cetera, et cetera. And yeah, I mean, the Git repository, and in particular the GitHub repository plus the ecosystem, I think has a lot of the missing pieces for that, right? So I think we are sort of updating our hypothesis to the fact that if we can bridge GitHub repositories with LLMs, there's something magical there about what we want to do. So that's what we're going to try to do today. We've done a bunch of work already that Ryan's going to show us, and we're going to take it from there. But long story short, I think we've pivoted a few times what we're doing, and I'm not really sure if we're pivoting this time again, although we might be. But I think every time we do that, it's for the best. Like, I don't think there's any value in staying committed to an idea just because you started it. Like, the point is to when you don't have the luxury of having just a massive team that can just keep going, it's extremely important to be focusing on a direct attack on the problem. And if you find that your direct attack is sort of hitting a bottleneck, you really should just take what you have, what you know, and attack the problem from some different angle. Yep. Ryan, I suspect you have thoughts to add.
Yeah, I mean, it's like, really, this is all, every time we attack it, it's about, there's the attempt to solve the problem and crack the nut directly, and then there's the building of intuition and discovering of new sorts of best practices about how to use the LLM and where it shines, where it's weak, how to compensate for those weaknesses. And every attack gets closer because ahead of time where some of the pitfalls are, right? So you speed run through the ones that you know about, and then you run into the ones that you didn't anticipate, right?
Right.
And then eventually, that runs into a wall, and you're beating your head against that wall. So it's worth taking the 2 steps back and saying, okay, given these new pitfalls that I'm aware of, what's if I were to start with a fresh sheet of paper, what is that attack look like?
Right. Yeah, because I think you articulated well the part I meant about, when you don't have a massive team. Because if you have a massive team, you can sort of just say, okay, well, one team sort of goes and fights this problem, right? So we don't have to change our plan. Now, that might not be a good idea, right, to do. Actually, I don't think it's a good idea to do. But that's how you would handle it with a big team. You don't, changing course is considered a bad thing, right? So you kind of want to stay on course. So, and it's also a lot more expensive to change course with a big team. So fair enough. But
there's a consideration that has to be made for your customers. If you're a company and you've made a product that they're using, right, you can't just.
But even if you don't have customers, just like getting everybody on the same page about what it is you're doing now, sort of thing, is like such a big task that you do almost anything to avoid it, right? And again, these are terrible reasons for staying on course and doing a thing that is not the best attack at the problem. I mean, this is the reason I think why we've constantly chosen not to sort of expand our circle of collaborators, because when you are in search mode, you don't necessarily, you haven't gotten the confidence that you're gonna stay on track for a long enough time for it to be worth bringing up to speed several people and being able to have some certainty that for 6 months or whatever, we're going to still be on this track. Yeah. So, okay. With all of that behind us, I think what we're going to look for today, at least, is how to automate a GitHub repo to the limit of what is possible by existing things, right? So we're going to try not to make new things, but just to find existing things that we're going to assemble. Some of them we've done already, and we're going to sort of walk through them a little bit. And then we're going to try to find more things, put them together, figure out how they go. Maybe do some design work, like, sketch through workflows and try to see like what we have and what's missing and whatnot. And we'll see what the limit is.
Yep.
Okay, so Ryan, do you want to show us where we are, what we've got, and where's the?
Yeah. A second. Window.
Oh, look, it's us again.
All right. So go into. So here's our little workflow runner. I think we've talked about this on stream. Doesn't have a README yet, of course, but this illustrates basically what we're on about, right? We want to be able to define a workflow and almost have it treated like an Excel spreadsheet, right? Where you have these functions, and this function declares, like, just in its arguments, I need the result of the fetch data task, right? And you want this little runner to just, analyze, lift out the dependencies, and run through it with whatever the maximum concurrency is. So that's sort of what our repo is. And the first thing that we implemented in terms of automating this is semantic release, which basically just uses the commit log on a push to master to determine whether an upcoming release should be a minor, major, or major, minor, or patch release, and does so. So that's all set up in this.
Well, it also, based on that, it creates a new version, which I think is what you're talking about, but it also releases it to NPM, right?
Right. So this is implemented. This is very cookie cutter at its time, but it basically, just runs, checks out the branch, audits everything, runs tests, and then does a semantic release process. Right. So this is sort of step one of what we would want, because we were talking about this earlier off call. You almost want the principal interface for improving the software to be the GitHub issue, right? So you start out everything by opening a new issue saying, okay, this code is broken. Or, I'm getting this weird behavior. And then through some combination of, bog standard automation and LLM calls, you actually, devise a new test, add it to the test suite, note that it's failing, find out where the bug is, fix the bug, and then, commit that bug fix with the appropriate, what's it called? I read it as Angular style commit measure.
Yeah, I think the sort of official method name is conventional commits,
right?
Or maybe the two have diverged actually. But basically, the Angular code base had innovated this idea that lots of people liked, which is it basically used a prefix to kind of say what kind of commit this is, and then it would. Basically, that enables some automation to gather up all the commits, make automated change logs, do all sorts of interesting things.
Yeah. So that's that's one place we're at. I will just briefly explore this folder in our repo. So some of you will know that we have another library over here called OpenAI Q. And this came from just noticing that when I was doing Node-RED stuff and various other attempts to sort of crack this automation thing, one of the quickest things you run into is that you run into your minute-by-minute rate limit with OpenAI. So this is just this creates a leaky bucket queue for each model that's initialized to the default rate limits, both in terms of requests per minute and tokens per minute. So you can just load it up with requests, and they'll come back as fast as OpenAI will handle them. So it takes care of your queuing and your error handling and whatnot. And then in this repo, probably doesn't belong here. Probably belongs closer to the workflow thing, but it's one of those things where I just put it in here and said, fuck it, I'm going to reorganize it later. Is a new sort of agent class that was built to take advantage of the workflow runner that we wanted to use. Because one of the hard things is, managing this tree of conversations, right? And saying, okay, where am I going to retain context? Where am I going to throw it out? How am I going to set and reset the system messages? How am I going to hand things over from GPT-3 to GPT-4 to some other completion set? So this is just a really simple little class that effectively, it just gives you a function, and you pass a string to that function as your chat message. It does the chat, and then it returns a new instance of itself that has the history from up to that point. So you can sort of treat, if at any point you want to branch a conversation, you just save a reference to the return value of that conversation. And every time you call it, it will create a new branch for you. So this being something that you could pass through your workflow generator, such that if you use that as a dependency, then you know that in that dependency, you've sort of got an immutable reference to that one node in the chat history. So you can say, given these requirements, give me a test suite. And then from there, you can say, okay, now I have a test suite. Now I want to get the implementation. Now I want to generate a README. Now I want to do these things. You can sort of branch them off real easily, and you don't have to worry about accidentally overwriting state or history anywhere there. So I used that basically as a way to bootstrap this workflow generating code. So, the workflow is a DSL, but before we have the runner that can run the DSL, you can express the same things in code with regular old ifs, else, awaits, and using regular coding control flow. So I've got a couple scripts here that do various things, like say this this TDD guy essentially sets up, it gets you your current description and requirements from the repo, and then asks the LLM to provide questions and potential answers to those questions in the form of new requirements. And it gives you a simple CLI interface to select, this is the answer I want, or this is the answer. And then it bundles those back into the requirements for you. This make tests one.
Does it assume a certain position for requirements in the repo?
Say again?
How does it know what the requirements are?
So you give it the requirements that you already have, and you say, ask me questions. So
I see.
Yeah. So it says, the user will give you a brief description of a piece of software and a list of requirements. Respond with a list of clarifying questions with the goal of discovering unstated requirements. After each question, give a bulleted list of potential answers in the form of it should ... statements as complete sentences. They should not require the inclusion of the question to be understood. And then the CLI basically just parses that out and asks you the question and gives you those as options. And you can also press other and then type in your own response if it doesn't give you the right one, if it doesn't give you an answer that you like. Um, so yeah, we've got a couple things. This debug loop takes the tests and the implementation. This is, it's very rarely going to get the right answer on the first try. You'll have failing tests. So this just loops through your failing tests, and you can copy and paste them into the terminal, and it'll give you a fix for each one in turn. But of course, you can imagine that all of this is going to go away once the workflow runner is running stably. Then we express this very flow as a workflow itself. And then we can bring that into automations. You can have GitHub actions that in response to a new open issue will create a branch or respond soliciting more information. So the idea is sort of you build out these LLM workflows, and then you tie them into your GitHub actions, such that eventually your whole flow is happening as a back and forth through the web interface of GitHub itself.
Right.
So yeah, that's kind of where we're at. Interestingly enough, I tried to make my first workflow today, which I can show. Effectively, the first pass of this, share screen. So the problem I immediately run into is, can you see this?
Yes.
So I've got task 1 logs 1 and returns 1. Task 2 logs 2 and returns 1 to uppercase. Task 3 takes 1 and 2. This will run 1, 2, 3 times. It will run the one task. So it's not doing what we want, right? Where we want it to just execute the task and then use it as a dependency. It's invoking that task each time it's detected as a dependency, which is the inverted behavior.
I don't get it. I don't get it. Tell me again. So this is, it's running 1, and then it's running 1, 2, and then it's running 1, 2, 3.
Yes, effectively.
Okay, so our code is wrong.
Yes.
Okay, well, we got to go back and fix that.
Yeah. So yeah, so I got it to generate me a new test suite, and we sort of started this stream where, unfortunately, it's in a cul-de-sac. But I'm thinking that we can back up, and now that we know that it did not intuit this requirement from the requirements I gave it the first time around, right? But now that I have this, I can say it should explicitly only run each task 1 time and then memoize the result. We should be able to.
Right. What do you mean memoize the result?
I mean, I'm referencing 1 here inside of the arguments for 2 and in the arguments for 3, right? It should only run the task once and then just reference that result for each downstream task.
No, that's not what it should do.
That's not what it should do. Okay.
No, it should plug the streams into each other, so that when it will run one time and pass the results to 2, and then run 2 once and pass the result to 3 as well as the result of 1, which is waiting, so that 3 will also run once. There's no memoization. It shouldn't need any memoization. Okay. I mean, memoization is an advantage, but not for this.
Implementation detail.
I don't think it's an implementation. I think we may have a different understanding between us what this is supposed to do.
Okay, then let's clarify.
Yeah. What I wanted it to be able to do is set up a graph of execution, like a Node-RED thing, right, basically, and then execute it one time and get 1 result.
Yeah.
So the memoization doesn't solve anything. It's just covering the problem. which is the misunderstanding that it's had from the beginning.
Right.
Right. Again,
at the end of the day, it should run each task exactly one time per run of the workflow, right?
Yeah, but I don't think that we should have to specify that. I think we should figure out what we said that made it understand something else.
Okay.
Can you show me? Okay, so how did you get the code that you've got here? Because I wasn't there for that moment. Like, what prompt created that code?
So the user will get. So I first gathered the requirements and wound up with this requirements list.
Can I see it? Okay, so this is. Is this the thing we developed together or something completely different?
This started from there, but there was it was asking it to do too much in one pass. So I pared it down into what I perceived as the core functionality of the library and left other things unspecified.
Okay. Well, that didn't work.
Yeah, evidently.
I think, yeah. But so what did you pare down?
I pared down the list of requirements that we had like last Thursday.
I know, but what requirements have been removed?
I can't recall.
Yeah. Yeah, no, there's nothing here about plugging things into other things. So obviously it doesn't get that.
It should pass the return value of dependency tasks as the appropriate argument in the downstream tasks.
Was that in the original requirements?
I think I reworded it.
Yeah, because this actually nukes the whole point about creating an implicit graph and sort of having the wrappers do a lot of the work. Okay, well, I'm lost. Like and this is kind of what I was afraid of, that you've moved ahead a lot now, but yeah.
Well, then we can. Here's the thing: is that we should be able to rerun the process. We should be able to change this to whatever we want and rerun the process, and get our output right.
What did you start with?
What? I started with like 3 shared ChatGPT things that were sort of in various states. So I just synthesized them as best I could into the core requirements list.
So what do we do now?
Well, I mean, the plan was to look at repo automation stuff, which is completely orthogonal to this.
Yeah.
So we can either dig into this if you think this is hair on fire, or we can continue doing that. Because I mean,
look, the problem we have is that we both should be 100% up to speed with what's there. Like, we should both be completely cognitively comfortable, but that reduces the amount of things we can each of us do without throwing the other out. And we also want to move at maximum speed. So, 1 + 1 = 26. So I just, as far as I'm concerned now, there's like 5 or 6 different things here I have limited understanding of. I know where I left it, and I know that it worked, but like the one you tried, remember the one you tried and fixed, that did the thing. That did the right thing without.
No.
Yep.
The last time we touched this, are you talking about like 2 iterations ago?
The one you fixed, like, remember when I showed it to you and you were like, no way. And then we took it and you sort of corrected some errors and you ran it. It ran each task one time.
Yes. But I could not find that leaving off point, because that's not where we left off last Friday.
Yeah. I hear you.
We left off in the middle of a speed run that was broken because we were too far ahead of our skis on trying to, because what we did on that second speed run is we started completely from a requirements list, right? And we built that requirements list up to too much, that it was too much to get done in one pass. And then we went down this road of the multi-step decomposition of the class into pure functions and stuff. And it was, I tried to rescue that and failed because it was too much complexity in a single pass. So
this thing you've got here generates the code in one ask, basically?
It's multiple asks. You make the tests first, and then you use the tests and the requirements to generate the code, and it generates a usage. Maybe that's what we should get into Google Draw and say, what is the bootstrap loop, right?
Yeah.
Because when we run into a problem in the bootstrap loop, we say, oh, we can handle this by this innovation, right? And we sort of meander our way there, but it's our compounded gains problem, right? We want just like take requirements.
We want a baseline. We want to be able to work. I mean, honestly, maybe the baseline you found with the OpenAI, what do we call it, Q or whatever. You should really never name things. But your enhanced client, let's call it. Like, at least there, whenever you find a good idea, you just add it on, and we can always use that library as our baseline for the next experiment. So that has that kind of feature, right? But I see the problem, right? And I don't really know the answer, because we are basically playing whack-a-mole, right? Like, you try to fix one thing and then the other thing breaks, and then you try to fix that thing and then something else breaks, and then we can't reach a comfortable point where we've got a level down where we're like, okay, this is there and we can rely on it, we can build further. Sure. So I mean, that's not true. We with the UI client, I think we did a lot, and we learned a lot, but we also built the thing with substantial capabilities.
I mean, this is just at this juncture. This is at iteration 0, right? Where it's just clearly.
So okay, let me share my own screen and just kind of figure out where I got to before I got hit by the disease. Okay, let me find. I think this must be it. All right, so basically, the latest version of it was this. Okay, and fair enough. It's a bunch of stuff. Am I sharing?
Yeah, you are.
I am?
Yeah.
Okay, you can see it, right?
Yeah, I can now.
Okay. So I gave it a bunch of things, and then I basically asked it to rewrite the specification below such that every requirement is orthogonal to all other requirements, but with no information lost.
Okay.
Right. So that's an interesting first step we could be doing, basically, like, because I was concerned that maybe some of my requirements were, hitting into each other or whatever.
Yeah.
So it divided it to workflow definition, task execution, task management, error handling, progress reporting, and compatibility. Right? Nice and clean.
Yeah. And each of those can be a suite.
A what?
A test suite.
Yeah. Yeah. And actually, that's what I told it to do, and that's kind of what it did. Right? 1, workflow definition; 2, task execution, etc. So that's where I have it.
Okay.
I don't. And then I basically got dragged into a flow where I started asking it to help me define a multi-layer bisect test style thing.
Right.
Right. And it kind of did a good work. And I was like, is it not known? And it's like, not really. I mean, it's kind of funny because it's known as, it's similar to test pyramid. I was like,
this inverted test pyramid.
Sorry?
It's the inversion of the test pyramid.
Well, I'm like, this pyramid testing allows skipping most tests most of the time. And it's like, no, it's just a guide on how many. I'm like, okay, so how is this any? Whatever. Anyway, so then it basically gave up. It's like, yeah, it's not a thing that exists. I was like, okay, help me describe it, whatever. I had a few ideas. And basically, then I just got it to create description tests and examples and stuff of how to run it. But basically, long story short, I mean, this is cool and stuff, and we should talk about it. But long story short, I got productively distracted into, talking about this, bug search strategy, let's call it. But I had this, so we can continue it, right? Like, I mean, again, it has this failing test, and the important thing is that, as you can sort of see here, it auto-generated the right functionality.
Right.
Right. The right syntax.
Yeah.
Yeah. So, this worked, so to speak. Oh, look at this. So, it's detecting circular dependencies as well.
Yeah.
Okay. But okay. So, I mean, I have this, but I don't know what to do. What would we do next from this? Let's say this is the cleaner version of the requirements.
Yeah. I mean, I think you start with each major section and say, generate me a thorough suite for this section.
You can't. That doesn't work though, because the generation of the suite is the generation of the interface, and if it's not aware of the suite that's been generated already,
it's going to generate a new. Yeah, so you need to generate from that. You generate the interface. I think the interface and type definitions are the first thing you generate after a spec.
By the spec, you mean the requirements?
Yeah. Well, I think this step is valuable, right? This intermediate step between a single bulleted list, and you basically get it to categorize.
Mm-hmm.
And then you generate an interface right? And then
What does
from
that mean?
you either
So what should I say here? Like, what should I say here? Instead of code of failing test suite, what should I say? What are you suggesting I say?
Generate me a TypeScript definitions and a usage and a thorough usage example for this library.
Great.
And you could even probably break that into 2 steps, because the usage example, I don't know. Like the usage example is basically, that's where you get a human, that's the thing that's friendly for human eyes to sign off on, right? And you couple that with your type generation, and then you can use the types generated to then generate your test suites in parallel, because they'll all conform to that type definition.
Yeah. Oh my God. Yuck. What is wrong with it? Nope. Sorry. Is it the TypeScript that's throwing it?
I don't think so. I think it's just, I mean, ask it to just generate a usage example.
Yeah, I think so.
Nope.
What in the world? Do you have the feeling sometimes that answers you're getting are somehow affected by previous answers, even though they're in different branches?
Yes. I can't tell whether that's just me hallucinating a ghost.
I know, exactly. It was never doing this before. This is completely new. So weird. Okay, I need to edit this.
Yeah. Here, let me. Take a look at that and see if something like that is acceptable to you.
Sorry, where are you showing me?
In the chat, in the Streamlabs chat.
The world is a mess. Software sucks.
Yep.
Should inspect each task function argument names to determine which tasks they depend. Yeah. I mean, it's overly specific. But also, like, what are you suggesting that I edit?
I mean, we want a specific interface, which means that interface is a requirement.
Okay, well, here, right, it says dependencies for a given task should be denoted by argument names that match the names of the tasks they depend on.
Mm-hmm.
Right, like this is pretty clear. Okay, let's give it another shot.
There we go.
I mean, I don't like any of this. That, you know, I had to do it this way, but and wait, what's the workflow here? Oh, okay, yeah. So tasks is the workflow. Fine. This is correct, right?
Yeah.
Yeah.
Now regenerate it 3 times and see if it gives you the same thing each time.
Is that like invoking Satan or something?
Well, you want to know whether you got lucky or whether it actually understood you.
Yeah. Oh my God.
So you got lucky. Go back to the first response where it gave you what you wanted. After it, yeah, let it do this for.
I'm gonna try to regenerate one more time.
Yeah.
Jesus Christ. This is so weird to me. I'm gonna guess it's not too.
I wonder if regenerations are like incrementing some like top p value or something, just to like inject more randomness, because it just assumes that like the default values didn't give you what you want. So maybe they're just. It might be that the
maybe though this works again, right? So at this point we're at 50% success rate.
Okay.
Wait, yeah. So you see, like, now it has tasks, and they take as parameters the things they want, and that's really the thing. And then it has some parameters, fine,
Yeah.
right? Like,
now, in that where you are right now, ask it, please review your usage example for conformance to the specification. And it should say. It should say yes. Permit tasks to output multiple values over time. Okay, that's fair enough. Now go to one of the bad ones and I ask the exact same question.
Yeah. You're right. I think actually I got a better question, which is this compatible? Because the other one basically listed the things it didn't cover.
Yeah.
Very good. Well, this is definitely an improvement. It didn't actually nail it per se. Oh, come on, man. Oh, Jesus. I think probably the path is to say, you know, does it match? And if it says no, basically you just back out and start over.
Yeah.
But okay, so this one didn't.
Actually, tell it to please grade the example using the specification as a rubric.
Yeah. Sorry. Just that.
Now, did you ask that on a good one or a bad one?
Well, it.
Like, let's scroll up. I don't know which branch you're
on. A good one.
Okay.
It's a good one.
Yeah.
I mean, it didn't give me a grade per se, but whatever. It says a line as well. So I assume if we pressured it, if we put it in a corner, it would provide a grade. But misses out on a few points, this one, which is true.
Now say, please fix any discrepancies.
Yeah, I don't know. It didn't answer the question properly. But this is better. Hey, you were right.
Except, here we go.
Except bullshit. Yeah, no, I don't. Once it gets it wrong, I think you just move on. It's not. There's no point trying to rescue it. Yeah. Let's try 3. 3 was wrong as well. With a few minor caveats. Yep. You want to try to correct it or just... What we know is that, the 4 times we tried it, 2 of them were good and 2 of them were bad, and that once you press on it, like I'm trying to find a way for it to distinguish, we're not demonstrating X from we are violating the requirements.
Yeah.
Okay, let me put it. Let me ask.
Please list all discrepancies between the specification and the example.
Not explicitly demonstrated.
Only include things that are demonstrated that are not true. I don't know.
Yeah.
Instead of list requirements, please list contradictions. Please list any contradiction. Yeah. Oh, this is interesting. It says no contradiction for the thing that we're carrying.
Where?
Second thing in that list.
Well, yeah, but it says, for instance, here it says, while it does not contradict the requirement, it does not fully illustrate it. Same here.
No, I'm talking about number 2. No contradiction. Task dependencies are denoted by argument names that match the task names. That's incorrect.
Yeah.
So that points to it's interpreting argument. When we say argument,
no, this is a good example that is grading here.
Oh, okay, my bad.
Yeah, does not contradict the requirements.
Okay,
so
let's
try another one. Yeah. I don't know if this is a new GPT or something, but like, it is super frustrating that it is not following instructions correctly.
Mm-hmm.
Like,
there we go. I found it.
Where?
Number 1, task dependencies. According to the requirements, task dependencies are supposed to be inferred from the argument names of task functions. However, in the example, dependencies are explicitly defined in the execute method call.
Okay. So long story short, I think we're reasonably confident at this point that while it is a bit hit and miss on the generation, it can course correct by identifying its own mistakes.
Can we try and perform that course correction on the third one?
Yeah, just this is another one that's wrong.
Yeah.
So so how do you want to course correct it?
Yeah.
How?
Oh, well, okay. So here, let's put ourselves in a mind where we have the workflow runner, right? What's the way that we actually fix this in the normative case, right? Do we
I would
generate?
want to do multiple generations until it attests that it matches until some level, right? And if it can't do, after 5, let's say, you're like, okay.
Okay, so let's change the grading request. So this found what we want, but we want it to end with a score out of one, with a cumulative score out of 100.
This is the best way I've got to say, like, parens percent. Um,
Fifty-fifty.
well, the problem is that it gave it a 0 here for not demonstrating things.
Right. Okay, so let's say ignore omissions are okay. You don't. The example does not need to demonstrate anything. It just can't demonstrate something wrongly. Are acceptable.
Yeah, I see. I think I noticed something that might be confusing it. So this, right?
Yeah.
You see it?
Yeah.
I think if I write it like this, it'll prevent one small class of confusion. Okay, let's rewrite the spec. Okay. So then, what was the next thing we wanted from here? Generate a thorough user example.
Yeah.
Huh?
Yeah. Usage example.
Oh no. Okay, I fucked up. What was our prompt? Remember? Do I have it?
Yeah. Yeah. You wanted it to grade, give it a score at the end, but the scoring didn't really.
Yeah, it found contradictions. Okay, so then we regenerate this, right?
Yeah. Well, I'm thinking actually what you do is.
Same fucking bullshit.
What did they do wrong this
time? This, like, it's not really the name of the.
Oh yeah.
Uh,
Well, it is.
let me confirm that it will catch this error.
No, it is, because when it puts it in the workflow, it's the key of the object.
Oh, okay. Yeah, that's cool. Okay, well, let's see if it. You're right. Okay, it found a contradiction, says.
Yeah.
Okay, well, yeah, so it figured out that this is correct, basically. I mean, we need to extract its answer in a more
for a tree of thought, right? You know, it's kind of a case for tree of thought. You generate 5, you get it to grade all 5, and then you pick the best one and say, please fix anything you noticed from the best notice that's wrong, and then that should get you to the best answer.
I mean, it's a smart GPT, really, what you want here, right? Yeah, like a modified one where there's it slightly modified, not even that much modified, really. You know what? Let me just try something. What was the thing?
Let's step by step to make sure we arrive at the correct answer.
Let's what this?
Let's take this step by step to make sure that we get the right answer. Although I'm super skeptical of this, because it's like, okay, what's the marginal utility of that? It was discovered by algorithm, and is it, if you swap get with arrive at, does that completely nuke the utility of the thing?
I don't know.
Yeah,
I doubt it. I doubt it nukes it.
Right. Yeah, you would expect the value to be in the signifier, not the symbol.
Yeah, I just, my reasoning was that if we are gonna do smart GPT, like might as well,
Yeah.
do it actually.
Okay.
I fucked up.
It did fuck up. So when I was doing the agent thing, I had a similar kind of problem where I wanted, I had a very clear idea in my head of what I wanted the API to look like, right? And how I wanted it to act, but I needed to iterate a few rounds to get there. So I think there's almost some, and for like a library, your interface is sort of, that's your design step. That's where the human has the most to say, right? Because you're like, I want this to look like this, and then you figure out how to do all the things that I want it to do. And I don't care how.
What is it even doing here? There's no way this will work. Am I missing something?
Can we try something else? Take one of the good examples and give it to it in response to the spec and say, I've been asking for usage examples. I get a bunch of bad ones, but occasionally a good one. Here's an example of a good one. Can you make this specification more specific to match this?
Yeah, I can try that. I need to. Okay, so here basically, right? You're saying
Well, you need to provide the example.
uh
You need to provide the example. Or did you do that at the end?
it already provided me the example.
Sorry. Oh, now it's just wrong.
Yeah. So that didn't work out.
Worth a shot.
Yeah. Okay. No, like honestly, we do have our path, right? Our path is generate and self-evaluate, and it does actually generate the right thing on occasion, and it does recognize it. And when it doesn't, it also does recognize it. So
yeah,
we have a reliable path to get to the thing we want. I mean, if you really wanted to do that, what you would do is you would wait. Actually, I have an idea. So the thing is, like, if you get a bunch of yeah, thanks, man. The point is, like, if you get it to specify diffs, then you can, instead of like hoping, you can actually try it. See what I mean?
yeah.
Yeah, you can. I mean, this isn't a good enough prompt, so it's not a good enough response. But if you say, like, look, these are my requirements. Okay, which one would you substitute and with what?
Yeah.
Let me just ask that actually.
No additional metadata. That's your magic phrase. A task is defined as a function with no additional metadata.
Where's the word no additional metadata?
It's not, but it says, for example, is a task a combination of a function and some metadata or just a function? So if you specify that a task, go all the way to the top and say task functions, comma, with no additional metadata. Or put a bullet line, a task function in a workflow must just be a function with no additional metadata. I think that'll pin it exactly where we want
it. Okay, let's see. Now, again, normally here you would ask it if it's dropped anything and whatever, but
yeah.
and even so. Okay, what was the requirement? The question we had again here. Yeah. Really? It didn't pick up the. I mean, this is implicitly the same problem.
Right. It's just it moved it.
Yeah. Okay, let's try again then. Oh my god. I swear to God that
I mean, this is just such a weird way of doing things, too, right? Like, this is. We're inventing a really magic feature.
what do you mean?
Well, this task dependency by analysis of function arguments, right?
I mean, this is doing it though. This is fine. Yeah. So I mean, this works. Anyways, okay. So long story short, I think we kind of know what to do here. But then what?
Now we go given the usage example, which has defined our interface.
Yeah.
Now we go case by case through the sections and generate a test suite for each section. So please generate
Right.
a just test suite for group one. And I mean, what I would do is actually, I would say, not actually, what I would do before that is generate type definitions
As a high level.
as an intermediate. So
Yeah.
you start with requirements, spec, usage example, type definitions, and then from there you branch.
Okay. So generate what TypeScript type definitions?
Yeah.
YOLO, whatever. Okay.
Well, I would actually continue down. Yeah.
Yeah. I just want to copy it. That's all.
Oh, gotcha.
So presumably I should try to, etc. I mean, it'll do it. What's this? Okay, that's fine. Very nice. See this?
Oh yeah, that's clever.
Beautiful. Okay, so long story short, it's doing the right thing here. Presumably, I mean, there's always a chance that it might slightly misinterpret its own example. Well, whatever.
Right.
No, this is, as far as I'm concerned, this is nice. Like, this is this kind of interpolation pattern I was talking about, right? Where it incrementally adds detail to its solution. And presumably, once you have the test suite, what do you do then?
Well, there's a question of whether you want to take the entire test suite and get it to implement it all at the same time, or whether you want to, on each of these branches, implement the functionality.
There's no way to implement the functionality on the branches. Like, you need one library, right? Not many.
Yeah, but you could carry the current state through the branches.
Right.
You could say, here's the current code, here's the test suite, here's the tests that are failing out of this test suite. Please augment the current code. It becomes similar to a bug fix loop.
Yeah, no, I got it. That's nice. That's pretty nice, actually. Okay, so we're doing it, but what's the, like, I mean, I guess, like, for tomorrow, can we, before we get into the repo business, I guess, like, could you write some code or whatever it is you want to write using the workflow or otherwise that will do this for us?
Sure.
Like, can you just take all of these ideas that we've basically put together? You've got a way to do this to automate GPT functionality, right?
Yeah.
And
can you share this? Is there a way for you to share this such that I have the entire tree?
no, but I think do you want the entire tree? Or, I mean, because if you get this, like, fine, it's not going to give you, like, I can just give you the group one branch, and then you can make the other groups.
If you can get me down to, there.
Yeah.
I think I can take that and hill climb it.
Yeah. Yeah, so basically then we'll have reliable code generation. And the point is, like, you've got the whole test suite, and then we generate the code to match the test suite. And we can do it over and over again, right? Especially if it has self-reflection, right, around its generated artifacts. Right, like, I don't know, what do you think?
Yeah. I think we basically want to hill climb that. And the trouble is, the if we're talking about the devil's in the details, right? There's how much by hand intervention is acceptable, right? Because let's say scroll up to the top of the test suite.
Here?
Yeah. So notice that it says, workflow DSL equals require workflow DSL, right? So obviously that's going to fail because it doesn't know where the file lives for the implementation. Doing this in TypeScript, it'll make TypeScript errors, either with regards to the types it's already defined, or a common one is that, especially in tests, it will try and access like a private property, right? Because it's trying to test it. So how the slow and steady way to do it is to be really rigorous about parsing out the markdown code block, like making it truly completely automated. Then there's the text-based interface where you copy paste in, and if a requirement path is wrong, then you just tweak it and say whatever.
No, I think we should do it properly. Like if the requirement path is wrong or whatever, like the prompt should basically there's
that's the first stuff
it's a sandwich. It's a sandwich method, right? First of all, the prompt should be really good, and secondly, after the output, it should evaluate itself to see that it matched, right? So if there's predictable errors like this one, right?
Right.
Can you tell me the error there that you think it'll hit and how we can prevent it?
Well, so it's trying to require a library that doesn't exist, right? It needs to be aware that it's in the same repo. So assume that assume that the implementation source code is located at relative path .. /source.
Yeah. Okay. Okay. Anyway, I can't continue at this point. But yeah, you get the point.
Yeah.
I need to run.
Okay. I can run with this. This is good. This is
a
clearer jumping off point than I had last weekend. And I've got.
Well, for me, the important part, I guess, what we missed is the generating the function stubs and then moving on to the functions. And I don't know why we dumped that, honestly, because the path we chose now is a path that still will not produce more than the context window. The path with the function stubs does produce more than the context window.
Yeah. It does. The challenge is that that's a back and forth, right? You generate the scaffold, or you generate the scaffold of the class with the stubs, and then you want to generate the test suite. So there's a more back.
No. You make the test suite first, and then you generate the scaffold, and then you fill in the functions. So in a way, what we did here is we generated the scaffold for the tests, and then we're generating the tests themselves. It's the same thing, really, the same idea.
Yeah, but that just gets you a multi-step implementation of the code. It doesn't because one of the big thing that you asked me to do last time was, let's just run the tests that have to do with the actual function implementation, so we know whether at what layer we're in with this error. But
no, well, what I said is that we generate the tests, then we generate the scaffold, then we generate tests for the functions, and then the functions. So I didn't imply any sort of automated sort of function. It's a test function correspondence or something. I said we generate the test for the function specifically, and then we test them based on the stubs.
Right. So that's a back and forth, right? Because you start with the overall tests, you then generate the scaffold, and declare what the stubs are, and then you go back to generating tests for the stub.
You don't go back, go forward. That's what I'm saying. You create, let's say you have 5 stubs, right?
Yeah, when I get that it's forward. It's when I say back, I just mean back to test generation.
Okay. Well, I mean, it's not back. Like, what I'm saying is you create 5 branches. Each branch is test and code.
Yes.
Okay.
Yeah.
Anyway, I'm out of time, and this is a big problem we have now, because we're just as we built enough context I have to run, but yeah, like the problem we have with the strategy that you sort of came up with, which I thought was good until now, is that by putting all the test suites one after the other and then running the code as if it was a production line, the code is always limited to what the size it can have. We don't have a way to break out of the context window. The big thing that was inherent in the method I showed you the other time was that you can break out of the limits of the context window.
Yeah. We compare these two things together.
How?
Because you're breaking down the functionality into each sub function, right? So you carry it through. Well,
no. The functionality does not pair with the functions. Functionality is holistic.
Yeah.
Yeah. So I think we generate a test suite however we generate it for the whole stub. Then we make the stub. And then we continue with test and function, test and function, test and function.
Yeah. Okay. So, then question. This is imperative. We have the test suite for the stub or for the whole thing, right? And then we've implemented the stub. Do we expect that test suite to pass?
After we fill in the stub?
Before we fill in the stub?
No. We don't. Okay. What we do is we write the test suite, then we write the scaffold, then we write the test for the function, we write the function. Once each subsidiary function passes its own tests, it passes its own tests, we plug them into the scaffold, and then we test the scaffold on its own test suite.
Got it.
Right. This is the thing I was saying. You generate code downwards, but you test upwards.
Yeah. Got it. Okay.
Right. That's the trick.
Yeah.
Okay. So, I mean, I don't know. It's a lot. This is a lot. What we just said now is a lot. But try to, automate as much as you can, and maybe we see where we are tomorrow.
Yeah. We'll do.
Cool.
All right. Bye.
Okay. Have a good one. Bye.
Thank you.
Bye, everybody.